So let's go to the next one, which is even more restrictive. So this one is actually a stored XSS, not a reflected, but we already explained what a stored is. What we're trying to talk about in here is ways of bypassing, protection, and filtering. So again, you should test everything, but I already know where the vulnerability is, and it is in this page in the comments. So we're just gonna put a test comment, and we're gonna put the name as test name. We'll put the email as whatever. And we will put the website as google.com. Put the post it, and let's go back to the blog. Everything looks fine. And as usual, you want to see where your data got injected, if it's being reflected within the code, all that kind of stuff like we said before. So you should look. Right now we have a number of things that we typed. We typed the comment itself, we typed the name, we typed the email, and we typed the website. So we basically want to see if any of the input that we typed is being reflected within the page. So you should test all of them. But again, to save your time, I'm not going to look for everything. I'm just going to look for the one that is actually causing the vulnerability, which is the website. So the website was google.com, and we can see that there was one instance of google.com, which is on this line. And we can see that there are two instances of it in here in the href and in here within the onClick event. So we covered a lot of examples where we were able to either inject code within the href tag or exit these double quotes in here and then inject it as an onClick or onHover or onError event, inject JavaScript code. We covered all that in previous lectures, and if you try it in here, it's actually not gonna work. Therefore, our next bet is to try to inject it in here. Again, you can try to escape these double quotes in here and inject it as a parameter, again on an event, or you can try to get the code to run from within this statement, because we know that the onClick event defines what JavaScript code should be executed when this name is basically clicked. So right now we already have JavaScript in here defined on the onClick event, but obviously we want to be able to run our own JavaScript code, not the code that the programmer is adding in here. So all we have to do, we can see that the website that we typed, which is https google.com, is being injected in here. So all we have to do is try to run JavaScript from within this constraint in here, from within this part of the code. So we can see that we already have an open bracket, a single quote, and then our string. Therefore, in order to start injecting stuff, so let's say our string is https google.com, it's going to be injected in here, and then you want to close this. So you want to complete whatever code you have in here. So you're going to have to add a single quote and a close bracket. So single quote, close the bracket. And then we know that every time we do this, every time we finish a statement, a JavaScript statement, we have to add a semicolon. So we added this. And then we know also that the programming language is already adding this to the end of whatever we type. And therefore we don't like this. We don't want this to interfere with our code. Therefore, we're going to add 2 forward slashes to define the rest as a comment. And finally, we want to add our JavaScript code right in here. So we finished this part is used to complete the existing statement, to insert it in here. Everything that comes after it is going to be considered a comment. All of this is a comment. And therefore we should be able to actually run JavaScript code in this part. So let's just do our alert, and we're going to say 44 this time and the semicolon. So we're going to copy this and let's just put another comment. So say test SSS, AA, put whatever, and we're going to put this as the website. We're going to post the comment. And if we go back, and this was what we're putting it, so it gets executed on click. So it's only when we click it that our JavaScript is going to be executed. Let me show you how I knew this. I didn't really just know. You can see that what we're injecting is within the onClick event. So we have to click on it. So if we click on it, you'll see nothing happens. We're just going to Google. So our JavaScript isn't being injected. We haven't discovered an XSS yet. So let's see what happened. So this is what we injected. We injected https google.com, but again, we have the same problem as the previous example. You can see the programmer has already programmed their web application to automatically add a backward slash whenever there is a single quote. They're doing this to prevent us from breaking outside of the string. Therefore, everything that we injected after it got considered as part of the string because a backward slash is being added in front of our single quote, which is telling the browser to basically ignore the single quote, and therefore we're not able to break outside of the string, and therefore we can't run JavaScript code. So in that case, we can basically try what we learned in the previous example. We just add double backward slashes. So add in another comment, we add another name and email. Now, obviously you can do this with the repeater, but it's easy enough to do it in here. So we're gonna add one backward slash because the web application adds another backward slash. So we're adding this, and actually I didn't need this. That was just part of the demonstration. So we're adding one backward slash in here, similar to what we did in the previous example, in hopes that when the web application adds its own backward slash, they cancel out and we will be able to break outside of the string. Let's post a comment, go back to the page and click on the name this time. And again, we're back to Google. Whatever we did not work. So let's inspect the element and see why it didn't work. And if you look at the code in here, you'll see that this web application is actually programmed better than the previous one. So when you add your own backslash, it actually adds two backslashes to make sure that they're not canceling each other. Therefore, the end result is you're going to have three backslashes, and therefore the last backslash is actually going to be used to ignore this single quote. Therefore, you're not going to be able to break outside the string, and you're still going to remain within the string, and you won't be able to run JavaScript code. When you're stuck like this and you don't know what to do, a good idea is to try to write a single quote in a different way. You can try different ways that the browser can interpret as a single quote. So let me just go back to the exploit that we're trying so far. And the problem in here is that we just basically need the browser to interpret this character as an actual single quote without ignoring it. We tried everything we know, it's not working. So the next thing we're going to do is we're going to try to type this single quote differently. And this is something that we actually use with a lot of different exploits. For example, in SQL injections, sometimes we convert text into hex because we're not allowed to use single quotes. So we try to say the same thing differently. Or sometimes you try to encode the string or decode the string, or use a plus instead of a space, or use two comments instead of a space, or use %20 instead of a space, or %27 instead of a quote. So we try to say the same thing differently. And one way of saying a single quote differently is using the and, a pause, colon. So basically all of this in here, if we're lucky, will be interpreted as a single quote, and hopefully the programmer did not actually account for this, and that way we will be able to escape his check, and then this will be interpreted as a single quote. It will close this string for us, and then all of this is going to be interpreted as part of the code. So let's try that. We're going to do this, type any name, type anything in here, payload in here, post it, back to the blog, and before we run it, let's actually just look at its code. And this time, note how we have https google.com single quote, close bracket, there is no backward slashes or anything in front of it, and the a pause got interpreted as a single quote, and then we have our alert 44, and this will be executed on click. So if we just go here and click it, as you can see, our JavaScript code gets executed and it shows us the alert message that we defined in here. So basically the take-home lesson in here is, if you're stuck and if you're not able to bypass whatever constraint you're in, even if it's not within XSS, if you're doing SQL injections or any other type of vulnerabilities really, Think of other ways that you can say the same thing. So maybe you need to encode it, maybe you need to decode it, maybe you just need to play with the characters a little bit. Try everything that is possible. Think outside the box. And in many cases, you probably would manage to actually get your code to be interpreted or your text to be interpreted the way you want it to be interpreted. So as you can see, the more examples you do with this, the more you learn. There's actually very small tricks here and there. And in the future, you might have to combine these tricks. So you might have to combine 2 or 3 or everything that you learned in order to discover one XSS vulnerability. But this is super useful in bug bounty programs and super useful when you're pen testing.